How's it going? This video is about applications of similar triangles. So it's like an extension of the last video we just watched. In order to be successful in this video, you want to know the 3 triangle similarity shortcuts. So I always like to just list them off at the top. That way I could, always see them up there. Okay, so keep in mind these 3 shortcuts as we're going through these examples. Okay? Another big idea is that you can't set up a proportion to solve for a missing side unless you have first proven that the triangles are similar. So I just want to practice real quick how we know if triangles are similar. So see if you can get through questions 1 and 2 as like a little warm-up. And I'd like you to pause the video now, and then when you're ready to check your answer, resume the video so that you can see if you have all the information you need or if you're missing anything that's important. So one thing that helps me while I'm setting up my ratios is to take a look at the order of the sides. So triangle's always going to have a shortest side, a medium side, and a longest side, unless it's isosceles or equilateral, in which case it should be pretty easy to match up the corresponding sides. But what I've done here is just highlight all the sides that are the shortest so that I can start to now compare, like 6 to 4, 4 to 6, or 6 to 6. Right? So what I want to be able to do now is to compare the other sets of sides. So when I compare 6 to 4, is it the same ratio as 9 to 6? So are these equal? And I can do my cross products to say that, yes, those are equal. And then I would just have my longest sides left to compare, 12 to 8. So 12 to 8, if I divide both of those by 2, it would be the same thing as 6 to 4. So now we've just proven that these 2 triangles are similar. So now I want to know if this triangle DEF is similar to triangle GHJ. So I can do the same thing. I can set up all of my ratios for the corresponding sides. So I've already compared the smallest sides. Now I want to compare the medium sides. So 6 to 10. Well, if I did my cross products, 6 times 6 is 36, 4 times 10 is 40. These are not equal. So right away I know these triangles are not similar. Well, if triangle DEF is not similar to GHJ, but it is similar to ABC, now I know that these 2 triangles can't be similar either. And you can always test it if you can't tell at this point by comparing, your medium sides. So 9 compared to 10, it's not going to be the same ratio as 6 to 6. So not similar, not similar. So to answer this question, the only triangles that are similar would be triangle ABC and triangle DEF by one of these 3 shortcuts. So that would be by SSS. Whoops. Okay, so one strategy that is also helpful when you have an example like number 2, where you have a triangle inside of a triangle, is to just redraw them separately. So here I have my small triangle, this one, and then SRT is my big triangle. So also it's important to keep in mind that this value, 12, is not the side of a triangle. It's just a piece of it. So you would need the 12 plus 4. So this side length would be 16. And then the same thing to find ST. You would want to add both of those segments together. So now it should be easy to match up the corresponding sides. But if you go back to our shortcuts, none of these are just SS. We need something else. And you may remember from a while back that a angle that is overlapping on itself is congruent to itself because of reflexive property. Okay, so that's how we're going to prove that the angle is congruent, and to use, my two sides, I would want to set up my ratios when I compare my corresponding sides. So when I do my cross products, I do get that the cross products are equal, so I know my sides are proportional, and therefore I've just proven, here's my two sides that are proportional and my one angle that is included in between the two sides. Okay, see if you can go ahead and answer these three questions that are part of number 3. You're determining if the triangles are similar, so your options again are AA, SSS, SAS. They could be not similar, or there could be not enough info. Here's just a few little hints as you get started. So again, when you are ready to check your answers, go ahead and resume the video after you pause. So actually all 3 of these examples are similar by AA. Some of them are a little bit harder to find because you have to use theorems that we've learned in the past, like supplementary angles. If the lines are parallel, then corresponding angles are congruent, or you could have also used reflexive on this one. And then on question 26, you had to recognize that this was a reflexive angle, but you also had to know how to rearrange this triangle to match up the corresponding angles that would go together. So the order of your letters is really important. So if you didn't have the correct order, I'd like you to pause the video now and just fix the order so that the corresponding angles are in line. Okay, so on to the applications. Now what we're going to be doing is using the concept of similar triangles to solve word problems and application problems that people actually do in real life. And there's a lot of similar triangles that exist in our world. It's just a little bit difficult to find them. So the first step that you always have to do whenever you get a problem like this is to first prove that the triangles are in fact similar. And what I can tell on this one right away is that 2 of these angles are already marked congruent for us. And then we have another set of angles that are congruent right here because vertical angles are always congruent. So step 1, we just proved that these triangles have to be congruent by AA. So they have to be similar, not congruent. Triangles are similar by AA. Step 2, we're going to set up a proportion. So when you set up your proportion, you want to pick out the parts of the triangles that match up. So I can tell that the 14 would correspond with the 7. We're trying to solve for AB, which is on the same triangle as 14. So I'm going to put the X on top of that ratio, and then that would correspond with the 5. I know that because X is in between my angles that are marked with 1 arc and 2 arcs, and so is the 5. It's between the 1 arc and 2 arcs. And then step 3 is we're going to solve. So now I have 7x equals 14 times 5. 7x equals 70. Divide both sides by 7. X must be 10. So the distance across this lake must be 10 miles. AB equals 10 miles. Okay, shadow problems are very common. So every time you do a shadow problem, what you want to be able to understand is that the sun's rays shining down on objects that are right next to each other are always going to be parallel. So all those concepts of parallel lines apply. And you know that the triangles are going to be similar. So here you have a set of corresponding angles. And anytime you're measuring height of an object, you're always measuring it at a right angle unless it's otherwise stated. So our triangles are similar by AA, and we're going to always set up this proportion. So unknown height to shadow A, known height to shadow B. This is called finding height indirectly because you're not going to actually take a measure tape or a ruler or a meter stick and go up the side of this building and measure how tall it is. That would be too difficult. So what we can do is calculate, based on a proportion, if our person relative to their shadow is a certain ratio, then the building relative to their shadow must be the same certain ratio. Okay? So if you would like to put some step-by-steps on your notes here, they'll pop up in a minute. Okay, so here's your 3 main steps. Step 1, I've already done. I've taken all the information from my word problem and I've labeled it on my diagram. Step 2, you're going to set up a proportion. Feel free to use this as a guide if you would like. So the unknown height, that's x, and the shadow that goes with that height, in this case, is 35 feet. The known height, that's the height of the person, 6 feet, over the shadow of the person. And then step 3 would be to solve. So go ahead and solve. When you have your answer, you can resume the video and check. So here's what you should get for the height of the building. And again, keep in mind that this is a real world problem. So hopefully you got an answer that was at least bigger than 6 and not too big so that it wouldn't make sense for the height of a building. Alright, question number 6 is a mirror problem. So the mirror problems are also very common because every single time you look into a mirror, the reflection of what you see is going to create congruent angles right here. And that's because of reflection properties, basically. So, again, you have one set of congruent angles. When you're measuring height, you're going to have 90-degree angles. So triangles are similar by AA. You can go ahead and set up your proportion by matching up the parts that go together. So the height of my person is 5.6. The distance from my person to the mirror, this is the mirror right here, is 4 feet. If I want to know the height of this model of Earth, that's going to be in the top of this ratio since the height of this person was in the top. We don't know what it is, so we're just going to put x. And then 100 is the distance from the mirror to the bottom of the height of that object. And then you can do your cross products. When you're ready to check, click resume. So when I solved this problem, I got 140 feet. Some of you might be saying that doesn't really make sense because the person is only 5.6 feet and it doesn't really look like this model is, more than 3 or 4 times that person's height. But keep in mind that diagrams may not be drawn to scale. So you can't always go by what you see. This one's kind of tricky, so I'm going to leave you guys to this for a little bit. I want you to see how far you can get. And then I'll start to explain parts A and B a little bit, but we'll talk about it mostly in class as well. Okay, hopefully you were able to answer part A by just looking for those vertical angles. Part B is kind of tricky because they don't give you the value of BX or XC. So most of us are probably able to match up these corresponding sides and recognize that BX would match up with XC, but we don't know what either one is. So what we want to do is assign a variable to one of them and then realize that together they must equal 3 miles. So I'm going to assign a variable to BX. If BX is equal to the variable Y, then that means XC must be 3 minus Y. So now I can set up my proportion. And then once I have my proportion set up, I can do my cross products and solve for the value of Y. So I get that Y is the value of 3/4 of a mile. Oops. So now I just found the value of BX. It's 3/4 of a mile, or 0.75, however you want to write it. That's the value of BX. 3/4. Now, hopefully, You remember what Pythagorean theorem is. If you don't remember Pythagorean theorem, I would go look it up or go back to our old notes and then see how far you can get with explaining the last part.